Okay, in this video, I spend time going over a template that I developed in Excel to help you do project management techniques, specifically identifying both the critical path and the probability of meeting a due date. And so this video is the most important video to do the homework and using the video. The other videos you really don't need because this template does a lot of this stuff for you. So after you watch this, you should be able to do the homework, and it will replace the activity on node, the critical path example, activity times, critical path. All of these I've already done for you in this template, including meeting due dates. This one you probably should watch because it talks about the cost trade-off when you throw resources at activities to shorten the project length, and how to construct Gantt charts in Excel. Well, where is the template? The template is in the last worksheet in the lecture data file. So when you open up the lecture data file, this is what you're going to see. It's going to have a series of worksheets, but the one you really want to focus on is this one. And I'm going to modify it and show you how to use it to do problem 15 in the book, which is one of the homework problems. So the problem 15 in the book, they give you that you have A through G activities. So A through G. So I like to always just use the bottom ones. So I'm going to put A, B, C, D, E, F. That should just be F, G, like that. And then it gives the predecessors, but now it's giving us the optimistic and probabilistic times. So I'm going to replace all these and put in numbers. So for A, this is 1, 1.5, and this is right out of the homework. So this is the optimistic time. This is what happens ideally. This is what happens most often. That's the mode. And this is a pessimistic time. Then 3, 4, 5. The units of measures of this is months. So all these numbers are months. 1, 2, 3. You can see some of these activities are symmetrical. So it's equally. I mean, you've got the best case and the worst case are 1 month away from the middle. But like the very first one, it's not symmetrical, and it doesn't have to be. Next one, 3.5, 5, and 6.5. And they're there. They're just, I've got them, I guess I could show these and display them as there. 4, 5, and clearly we have this one where we have an upper right tail. 6.5, 7.5, 11.5. 5, 9, and 13. So once you input these, look what it does. It automatically calculates what the expected time is. And the expected time is 1 part this, 4 parts this, 1 part this, divided by 6. So it's a weighted average, and it also calculates a variance for you. And the variance is the pessimistic minus the optimistic squared divided by 36. So that's that formula. So this is done for you for free. The other thing that it automatically does, it's going to calculate something called the earliest start, earliest finish, latest start, latest finish for you. And to get more explanation on those, watch these other videos to see what those mean. But the final thing you have to do is that you've got to be able to construct the precedent relationships. So in the book, it says that activity A does not have a predecessor, so I leave it blank, but activity B has A as its predecessor. Activity C has A as its predecessor. Activity D has B and C. Activity E has B. Activity F has C, D, and E. Activity G has E. And then F is always the last one. I mean, finish, you want to have the finish. And the finish, how you know that is that if it's not listed as a predecessor, it needs to be linked to the finish node. So the immediate predecessors, what's listed there is A, B, C, D, E. There's no F or G, so F and G. Whoop. There. So there you go. This is, you got to construct these from the book, and then after that, it calculates all of your earliest start, earliest finish, latest start, latest finish. So on average, this project is going to be done in 21 months. That's what this is telling me, these numbers here, when it will be done. So the average expected time, but that also calculates the variance for you, and it calculates the standard deviation. So what it does, it sums my variances and then takes the square roots of those if they're on the critical path. And so that's how that number is calculated. So now we have a project that averages 21 months with a standard deviation of 2 months. So the question is asking, what is the probability that the project will be done in 27 months? So now I can input over here 27. So the probability that a project that averages 21 months with a standard deviation of 2 will be done in 27 months with a likelihood of 99.846. So we just did problem 15. If you would do this by hand, it would take a lot longer. So this template, now there's things below here from row 28 down you don't need. If you want to see how I constructed these, have at it. The inputs for these are, you've got to input these, you have to input these, and you have to input the due date. Those are the inputs. Everything else you don't have to put in, and it will calculate this probability of meeting a due date, as well as telling you the critical path, which runs through A, B, E, and G. So watch this template will make your life easier for the class. Thanks.